In this video, I want to have a look at applications of integration involving exponential functions. So we've already had a look at how we can use integration to calculate areas and volumes of solids of revolution. But now we're going to have a look at those same similar sort of questions, but involving exponentials. So our first example, if we take the function e to the y equals e to the 3x. Now I want to calculate the area between that curve, the x-axis, and the values x equals 1 and x equals 4. So I want to calculate the area of this region here. So to do that, we're going to integrate. So our area is going to be equal to the integral between our upper and our lower bounds, so our 1 and our 4, of our function, so e to the 3x, with respect to x. Now to calculate this, we're going to have our e to the 3x over 3, so we've found our primitive, and we've got our bounds, and we're going to substitute our bounds in and then subtract. So we would have e to the 3 times 4 would be 12 over 3, minus e, and if we sub 1 in, we'll just have e to the 3 over 3. And we could write that just as one fraction, so we could have e to the 12 minus e cubed over 3. And that's going to be units squared because we are talking about area. All right, let's have a look now at a volume question. So let's have a look at the equation, just y equals e to the x. And I want to find the volume when the region between x equals 0 and x equals 5, so this region here, is rotated around the x-axis. So I want to find the volume of the solid that's formed. So our volume is going to be pi times the integral between our bounds, so 0 and 5, of y squared. So y is e to the x. That means that y squared would be e to the power of 2x. So that's what's going in here, our y squared, e to the 2x, and we're integrating with respect to x because we're rotating around the x-axis. All right, so doing that, our pi will stay out the front. We've got e to the 2x over 2 between 5 and 0. Substituting in, we'll still keep our pi out the front. We'd have e to the 10 over 2 minus e to the 0 over 2, but e to the 0 is just 1, so minus a half. And we can just pop all that together, so we could have pi outside of e to the 10 minus 1 all over 2. And that's units cubed this time because we're talking about volume.